it was not mentioned anything. So we'll assume it to be somewhere here, and we'll proceed with the problem. It is something related to some mathematics. I'll write down the equation. I'm not sure like such lengthy questions can be asked and directly. So first of all, we have to show the mathematical treatment, then we can enter into the options given. So the question will be, there's no electric field. There's no electric field. Okay, I'll just proceed like this. Just you see the basic mathematics. So here, the moment I release, how the weight mg will act vertically down. There's a positive charge particle. So because of that, it will acquire velocity vy. mg and let this be vy. So why do that vy? Because of the weight. There is no electric field here. There's no electric field. That's why you try to make observation. Then b bar into the plane, b bar and the velocity. So there should be magnetic force acting in the direction. So because of this, what should happen to charge particle under action of weight mg, and say like initially it's released from rest. First it will accelerate. It will acquire velocity along y-axis, and because of y component of velocity for t greater than, there will be y component of velocity, and because of that y component of velocity, the magnetic Lorentz force Fb will act, and what should be the path? It is going to deviate. It's going to deviate here. So again somewhere at this particular point, you look at the charge particle position. It will have some velocity v, weight mg, and b bar, the magnetic force will be acting in this direction. And we know so because of the weight, what happened? The v should be greater than vy. The velocity of particle I'll call v1. V1 should be greater than vy. The y component of velocity keeps on increases, and at the same time, the magnetic field will make the particle to rotate. It will change. It will introduce change in direction of motion. Okay, fine. So after all this, the motion of particle will be directly. Let's come to the option later on. I'll bring that. So let me. Yeah, this one. So here we'll take the reference point. The path of particle this is initially point A. It will be I'll give mathematical proof. So why only like this? I'll give mathematical proof. Okay, keep it now. So this is what that A, and this is C. Let me take this is B, and let it be D. So what are the forces they'll be acting? Acceleration due to gravity, and B bar is into the plane, and it's a positive charge particle. At t equals 0, it will start from rest. Release it. Let's begin with the mathematics here. So and I'll define the coordinate system. Let me take this is the initial coordinate system. Let it be x comma y, or here only. So what are the forces that will be acting on it? The weight of the particle minus mg by j cap. Then magnetic field, how it will be directed? Minus bk cap. Let's write here. Now at any instant of time, so what will be the velocity of the particle? Let me take V here. So somewhere here, what is the velocity of particle will be? Vx I cap, Vx I cap minus Vy j cap. So the velocity of particle at any instant of time. So the total force acting on particle should be minus mg j cap plus V bar cross B bar. So this should be Vx I cap minus Vy j cap cross minus of bk cap. Let me further expand this. So I cross k, this will be, so if I solve it, I'll end up everything. This is qv xb minus mg j cap. Okay, first let me write I component. So what is this? F bar should be equal to q b vy I cap q b vx minus mg j cap. Expanding that bracket, cross product, then grouping all j component of terms, because one j and another I cross k, j will come, j cross k, I will come. So finally I'll end up this much of equation. Okay, keep it. So now what is F? F should be like the total force, the resultant of FB and mg. That's what I wrote it. So this should be equal to m dvx by dt I cap just only mathematics, are there, no concept, nothing. So you should just carry on the mathematics. Equate quotients of I cap. So this will be m dvx by dt equal to qb vy. Call equation 1. Similarly, m dv by dt is equal to qb vx minus mg. Call equation 2. We have to solve this. So we have to get expression for x and y. Looking at that x as a function of time, we can predict this is at t equals 0, this is at any time t. We can predict, okay, what should be the path of that particular equation. Since I already know this problem, I'm able to tell Cycloid. Otherwise, no way, nobody can make a guess. Nothing to do. Just nothing to do that one. Okay, let's proceed. Nothing problem that one. See, like there's nothing called like a positive, negative. In general equation, you see that look at the path of particle. It will not just move only along negative y-axis. No, look at the path. Okay, let me differentiate equation 1. Differentiating with respect to time t, m d square vx by dt square is equal to qb dv by dt. Call equation 3. This equation 3, I'm going to substitute in 3 in 2. So that I'll get expression for Vx, that one. Put 3 in 2. And I'll take it out. Yeah, tell you. Put 3 in 2. Wait. I'll conclude in the end. No need to bother. Listen patiently. Then nothing to do bother that one. Plus or minus, you in the end you can see that it's a harmonic function. It doesn't matter for you. Okay, substituting this, m equal to dv by dt, no? M dv by dt. M dv by dt will be m by qb d square v by dt square equal to qb vx minus mg. So this will be d square vb by dt square qb m whole square vx minus this will be g by bq g by m. Okay, there is some equation what we have. So can we solve this? It's a second order differential equation. Keep it here. So let it be equation 4. Now similarly, let's differentiate 2 with respect to time. Differentiate equation 2 with respect to time. So m d square y by dt square equal to qb dvx by dt minus 0. M and g will be constant. Substituting, so let me take this equation 5 numbering, put 1 in 5, d square vy by dt square equal to qb dvx by dt will be qb by m vy. So therefore this will be a generalized equation, d square vy by dt square equal to qb m whole square into vy. What all that negative sign you were saying, no, that will have impact here. I'll agree. The acceleration, it should be negative, no? So that negative sign, what earlier I said, no, it has to come here. The negative sign, it will come. So again, you'll get confused. That's why I just took that one. It should have been minus m j cap here. Just let uniformly. So this is something related to SHM. What is the general solution of this? General solution for this. Solving. So this is equation 6. Solving equation 6. So we'll get expression for Vy is equal to V naught sine omega t. V naught is not initial velocity. Yeah? It has to be determined. If you want to bring some other symbol, U or something, you write it. Again, you'll get confused with this. Let me write U. Vy equal to U sine omega. So Vy is equal to this one. Let me differentiate this. dVy by dt is equal to U omega cos omega t. Let's go for initial condition. At t equals 0, what is the value of dvy by dt? U omega. And what is value of Vx? Vx will be 0. What is the value of Vx? Vx will be 0. So therefore, can we bring any equation with the help of this? Just see once, I'll scroll down, page got over. I don't have any space. I'm just putting the initial condition. So dvy by dt, put t equals 0, it will become equal to u omega. Then initially, what was the x component of velocity? It should be equal to 0. Okay, then take help of, from in equation 2, you substitute these conditions. dv by dt put these in equation 2. And I'm
Sir,
wait. In the end, you can come into picture. No, nothing to do. So now substituting this, put these in equations 2. So we'll end up with, okay, that I'm putting the blocks also. So this will be m dv by dt value is u omega is equal to qb. This will be 0 minus mg. So u omega is equal to g, it will come. So that negative sign, what all I earlier said, no? So minus j if you take it, so it will come. So it's only magnitude. Huh? You just bother about only magnitude, that one. Okay, now after getting this, so I got now what is value of u, because we assumed it, no? So now I'll write down the equation. So what is omega equal to what? You can write it as u omega equal to g. Omega is what? bq by m. So in place of u, what we can write it now? In place of u, I can write it as mg by bq. Now I'll write the equation for Vy. Vy is equal to, call this is, I think, what is the number? This is 7. Okay, this is 8. Put 8 in 7. Vy equal to mg by bq sine omega t. So let me write further this as dy by dt. I will integrate it now. Mg by bq sine omega t dt. At t equals 0, y coordinate is 0. At any instant of time, let it be. So y is equal to mg by bq minus cos omega t 0 to t. So what is the value of y will be? Mg by bq 1 minus cos omega t. So this is the equation 9. So I got y. Now similarly, I should get now the x here. Again, for x, what happen? I'll take help of this one. I know value of Vy, no? So directly I'll substitute there. Expression for Vy, we know it. So this is the 9. I'm giving numbers. You can follow that numbers. Huh? Okay, now put 9 in 1. I'm showing 9 in 1. What is 1? M dvx by dt. Substitute the value of Vy there. Solve for it. You'll get expression for x. So this should be equal to m dvx by dt. dt equal to qb, Vy equal to mg by bq sine omega t. M get cancelled, bq get cancelled, so dvx is equal to g sine omega t. Integrating 0 vx 0 to t. So what is vx will get? G into 1 minus cos omega t. Equation 11. Dx by dt. G dx by dt is equal to g 1 minus cos omega t.
G by omega.
What is omega? We equated G by omega. What you can write it as? Let it be that much only. Or omega is BQ by M, because all this is. So finally, the equation will be GT minus mg by bq sine omega t. So this is the equation 10, 11, 12. So comparing x and y, what happened? It's a cycloidal equation. The 10, 9, 12. Okay, I'll put in order. Now we have to go back to now rotational mechanics.
Sir, while integrating sin omega t, 1 by omega will come now, sir.
Okay, that one. I'll check it. What all left over?
Sir, how can you write omega equal to BQ by M? We are assuming omega. It is not the same omega as that.
Okay, you do one thing. Do whatever you want and give me other method. That's all. No?
Sir, there only you differentiated once. You got U omega equal to G.
Wait. So one omega should come here, no? Integration omega should be here. Huh? Okay, I brought it, no omega.
Sir, upper part, sir.
Y here. Huh?
Integral sin omega t dt, 1 by omega mg by bq omega will come now, sir. While integrating that.
This one, huh? This one. Huh? Okay.
Sir.
Yeah, wait. Somewhere. This one, huh? You mean to say?
No, sir, that one, rightmost one.
Here.
Upper part. Yes, sir.
Here. Integral of omega, one omega is there, no? Integral omega, I'll bring it here. Huh?
The below part also, sir.
Okay, let me come in order. So omega equal to BQ by M. Huh? Okay, fine. Yeah, this will be BQ by M. So this will be square will come here. Huh? G M by BQ whole square. Is it okay? Correction. Now here also dvx by dt. Here also one omega will come. After integrating, we'll end up with one omega. Omega square. So this will be again G omega. I'll erase it. We'll rewrite this one. Dimension it should match, no? Yeah. Okay, this should be x equal to omega is bq by m. So mg by bqt. This will be m we have x, and what is the equation y? Y was equal to gm square bq whole square 1 minus cos omega. So this equation 10, I'm rewriting. The 10 and 12, they represent cycloidal motion. I don't know whether you study in mathematics or not. These two x and y equation 10 and 12 represents cycloidal path. Any graph plotter is there you substitute this and just feed these equations. No, it will show the path. The path will be of like this. Cycloidal about what point? So about A and about the ground. Okay, now we have to directly enter into the rotational mechanics concept. So it will be now in cycloidal. What should be there's a point A. We have chosen C, B, and this is D. This distance should be equal to 2 pi r in pure rolling. Okay, this one. And what about the path length SACB? Should be 8r. And what is this? This is equal to h. And here it was released from rest. When it arrives here, the particle will have a speed. How much? Applying conservation of mechanical energy, because how mg will act like this. And what about b bar? B bar is into the plane. So what is the only force they'll be doing work? Only the weight mg. No. So therefore, what is the first thing? V equal to root of 2gh. The particle is at rest here. It will be in motion. It's a positive charge particle. Show that charge also. Very important for us. Okay, this is the path length from the SACB should be equal to 8r and this should be equal to 2 pi r. And t equals 0, we assumed it to be here. And t equal to capital T, it will be here. T equal to 2t, and this is the point B. So how much of time it will be from symmetry? So the here what time? T equal to t by 2. So what is the time period again? Time period is independent of speed and all other quantities, no? So 2 pi by omega 2 pi by BQM. So what is the time taken to move from A to C? It should be no. Time taken to move from A to C. So this should be equal to TAC should be equal to T by 2. So T by 2 will become pi m by BQ. This is one thing, and velocity V equal to root of 2gh. This is another thing. Okay, what about other things? SAC should be equal to how much? 4r, no? Because SACB is 8r. So here SAC equal to SCB should be equal to 4r. In relation between H and R, this is like a cycloid, this one. So what can be this distance will be? This will become equal to, this height will be 2r, no? It is as good as what you should do. Now you have to assume one more thing. It is as good as like a ring rolling on this surface. Go back to rotation mechanics. So the path will be like this, no? So this is the radius of the ring if you take it, and this is h. So any relation between h and r now. 2r should be equal to h. So that I'm going to take help of this one. So r equal to how much now? H by 2.
Sir, we don't know that at point C the velocity will be only horizontal.
It is there. You have to look at the mathematics here. It's a very proven. It's a very popular problem. No, you just think and analyze. Okay, fine. So this is about the mathematics involved here. Path length, it's in a rolling motion. Rolling motion, 8r it will come. Definitely. I think in exam, I don't know why teacher has given more or second order differential equation, that too solving all. I don't know, teachers. They just say, okay, 2-3 steps you write this equation, but cycloidal is not that part of syllabus, no? Cycloidal path and all.
Sir, from mathematics also we can't prove that at point C velocity will be horizontal.
Will be there, you try it. I don't have patience, first of all.
Sir, if we take any value of h, how can we be so sure that there will be that h is enough for the path to become like that?
It is a cycloidal path. There's no other way the particle, in fact,
I'm not
will move
telling
like
it is not a cycloidal path, sir. It is a cycloidal path, but I'm telling that that point might be above the ground. It might be below the ground. We don't know that.
He's telling no point greatest point C.
One more doubt, sir. How can we take omega equal to bq by m?
That's
We are
what
assuming omega here.
it's independent of speed, no? Finish over. Independent of speed means independent of any other things that are acting. Oh no.
Can you scroll up one, sir? I want to tell one more thing.
Ah,
Where you got omega, sir, for the first time? A little more up.
okay, yeah.
Here, if we differentiate equation, we differentiated equation 7. One time we got u omega equal to minus g relation from there. If we differentiate equation 7 2 times and compare with equation 6, we'll get different value of omega.
I don't know. Some mathematics you manage. You are messing up things. Okay, just look at once again. Once again, and